Okay, so this problem reads, what force does a trampoline have to exert on a 45.0 kilogram gymnast to accelerate him straight up at 7.5 meters per second squared? We want to make a note, just for your own information, that this doesn't matter what direction they're going or the velocity. So we're going to see about that because we're just looking at the forces. And we know that this gymnast then is our object of interest. So we're interested in that gymnast. We're going to go through, I did not spell that right. We're going to go through the process to really examine the forces acting on that gymnast. So let's draw a picture. Here we have this gymnast and they're on the trampoline, and we can imagine that that trampoline is flexed and that trampoline is going to exert an upward force. So let's first look at the interactions on this gymnast. What forces are acting on the gymnast? Well, we know that it's interacting with gravity because all objects with mass interact with the earth. So there's a force of gravity between the gymnast and the earth. The gymnast is also touching the trampoline. So there's a force by the trampoline between the gymnast and the trampoline. It's interacting with the trampoline. And that's it. That's the only thing those two that are interacting on that gymnast, the earth and the trampoline. Okay, so we're going to draw a free body diagram of our situation. We have the force the earth acts. Well, we know that that is vertically downward. So here's the force of gravity. And just as a reminder, that's equal to mg. What's the trampoline doing? Well, it's acting up on the gymnast. So we also have the force that the trampoline is acting on the gymnast. Now, why would I have drawn that arrow a little bit bigger than the force of gravity? Well, we're told in this problem that the trampoline is accelerating the gymnast in a positive direction at 7.5 meters per second squared. So if the acceleration is positive, then that force has to be positive. And if that force is positive in the upward direction, that means the up arrows are bigger than the down arrows. There are only two of them. So our up arrow in this case is likely, and in this case is, bigger than the down arrow. Okay, so we're trying to figure out the force that trampoline exerts on the gymnast. So we have our two forces, force 1 and 2, and we're going to look at both the horizontal and vertical components of those forces. Well, force 1, there's nothing horizontal. It's pointing in the downward direction, so we have a minus. I'm going to be explicit about that direction, external to my magnitude. Force number 2, also nothing horizontal. There's nothing going on horizontal. And it's positive, so we have the force of the trampoline. So the sum of these forces, that's our Newton's second law, the acceleration times the mass, and that acceleration is in the vertical direction. So I can sum these up. Minus mg plus the force by the trampoline is equal to the mass times the acceleration vertically of that gymnast. So I'm interested in the force of that trampoline. I'm going to bring the force of gravity over to the other side. So I'm going to add that. So we get the force, the mass times the acceleration plus the weight, the force of gravity. And so we have the mass of the gymnast, which is 45.0, times our acceleration that's given, which is 7.5, plus 45.0 times 9.8. Nope, and that went a little bit off screen. Let me move that over just so we don't lose our picture there for you. All right. And when I add these two together and do that mathematically, we get a force of 780 newtons in the upward direction acting on that gymnast. Okay, so we didn't care what direction she was headed, and we didn't care what her velocity was in this particular situation. We're only looking at the forces. We know that the object interactions are just with the earth and the trampoline, and that upward force is larger than that downward force because we have a positive acceleration. She could be traveling down and slowing down, or she could be traveling up and speeding up. Both would produce the same force analysis on this gymnast. Okay, good job.